Hello again. Thanks for joining us on Space Nuts, the podcast about astronomy and space science, also heard on community radio across Australia. My name is Andrew Dunkley, your host. And coming up on this edition, we're going to be looking at the Square Kilometre Array. And the reason is because you can actually look at it because they've started building the thing. Yay! Also, some interesting findings by the James Webb Space Telescope. Mars appears to be active, much more active than we would have considered. Some new evidence has come to light, and a bit of an update on Artemis I, and questions about the end of the life of the sun and terraforming an ice moon. That's all to come on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me as always is his good self, Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you doing?
I am very well, sir. You are in sunny Adelaide, South Australia. You've been a busy boy.
Certainly travelling around the last couple of weeks. Yes, I had the great pleasure, as I think we mentioned before the event, but I had the pleasure of accompanying the Director General of the European Southern Observatory, Xavier Barcons, on sort of not a fact-finding mission, more of a celebration mission to be in Australia to celebrate 60 years of the ESO, European Southern Observatory, along with some of his high-level colleagues. We had a ball. We went to Perth, Canberra, Sydney, talked to lots and lots of astronomers, all of whom have very warm feelings towards the observatory because we're in the middle of a 10-year strategic partnership with them. So that was great. And then, to do with the Square Kilometre Array on Monday this wecome
Yeah, that's that dovetails perfectly into our first story because the news has come out that it's all systems go. We're starting to see the first signs of work in the ground.
Yeah, so Monday this week saw the news headlines. Actually, they hit the headlines all over Australia, which is brilliant, of the start of construction ceremony. So that was actually at the site where the telescope is, the Murchison Radio Astronomy Observatory, also known as Inyarimana Ilgari Bundara, in the Wadjuri Yamachi language.
You've been practicing that, haven't you?
It's better than the last time I tried it.
Sure.
It's a lovely name, actually.
It is.
It means sharing stars and sky.
Nice.
And was arrived at after a lot of thought and consultation with the Wadjuri people. And so I wasn't actually at the celebration at the site on Monday. That was the ultra VIPs, the our Minister of Industry, Science and Technology, and some very high-level people from both the observatory and the government department that I work in. But there was a very nice celebration in Perth, in the city of Perth, in the evening. All the VIPs came back to join us for an evening of well talks and videos, some quite inspiring speeches made. The real buzz around the room, of course, was exactly what you said. Construction has now started. And it wasn't just a celebration of construction in Australia, because the South African component, the mid-frequency component of the Square Kilometre Array, has also kicked off. We had the Director General of the Square Kilometre Array Observatory, Phil Diamond, who normally resides in the north of England, which is where the headquarters is. He was out there, had a chat with him. Celebrations all around. We had a link to the UK on the internet, and that was good too, to see people over there helping to celebrate the start of this construction.
Yes, it's not a cheap thing to put together. What, $3 billion?
Yes, that's correct.
Of course, in US dollars, that's $5.50.
No, that is Australian dollars, 3 billion.
Yes,
I mean, that's the thing about, mega projects like this, Andrew, that the only way you can build them is to have international collaborations. And so the Square Kilometre Array Observatory, I think it's 15 nations. I should check that, but it's that sort of number. Australia's contribution will be 14%. I think a lot of that's already been paid up front, and so it's very, it is expensive. But the promise of what we might learn from it, and in particular, probing the dark ages of the universe, that era in the universe before the first stars switched on, where the telescope will be able to see the glowing clouds of hydrogen glowing in the radio frequency. Cold hydrogen emits radio waves. They'll be able to map those and see, how the hydrogen that eventually formed the galaxies, how it was distributed.
Yeah.
Requires enormous sensitivity. A statistic that came out of our discussions on Monday that I love is, if you think of an astronaut on Mars, and she has a mobile phone in her pocket, which is switched on, well, the Square Kilometre Array will be able to listen in on the conversation.
No way.
It's amazing.
Wow. It is incredible.
Yeah.
Yeah, I think it's really exciting that the technology has advanced to a point where we can do things like that. Obviously, with the James Webb Space Telescope, which is a completely different system, this will work hand in hand, I suppose, to some degree.
That's right. So that's the thing about all these big facilities, that the science that they do dovetails together. And again, it underlines the international nature of astronomy, Andrew, because, if you've got individual countries, you could imagine them all vying for national prestige by building something that somebody next door has also built. But that's not the way it works, because these things are expensive and very, very specialized. They're built in such a way that each one of them provides complementary evidence. So the Webb telescope certainly, in many ways, fills the gap between visible light or optical astronomy and the radio spectrum. That when you think about the kind of instruments that you use, you've got the big visible light telescopes, you've got the Webb telescope in the infrared. We have the ALMA telescope in northern Atacama, which is the millimeter and submillimeter wave, that region between the infrared and long wavelength, and then the Square Kilometre Array filling in the long wavelength stuff. It's really remarkable.
It is. When do we expect it to be operational?
Well, one of the great things about an array telescope like the SKA is
you can turn it on a bit at a time.
You can, you can turn it on a bit at a time, and that's the plan. So maybe within 2 years of construction really getting going, we'll start to see scientific results. But the complete telescope will not be operational until 2028. So we've got 6 years to wait before we see its full range of capabilities.
And hopefully it will provide exciting news like the James Webb Space Telescope, because hasn't that been just one of the big success stories of 2022 in astronomy? And we might as well move straight on to that, because yet another discovery has been announced by the James Webb Telescope. This is, I'll let you explain. I have read this story from a few sources over the last week or so, but it looks like it can see through things that were blocking our view, and we're making these amazing discoveries because it's unveiling the universe in some respect.
That's right. So this particular research, which has come from the Astrophysical Institute in the Canaries, in Instituto de Astrofísica de Canarias. And I used to have quite a lot to do with the people there. It's the Canary Islands Astrophysical Institute. Of course, the Canary Islands have many big telescopes on Teide, which is on the main island. The island of La Palma has the observatory there that, in fact, has telescopes I used to work on quite a lot. So it is a very active organisation. And what they've done, some of the scientists from that institute have basically taken James Webb Telescope images of galaxy clusters. And there's one in particular that they've been studying, which is called SMACS J023.3-7327. Don't forget that.
I already have.
And so what they've done is they've looked not just at the galaxies in that cluster, but at the space between the galaxies. And so by analysing a really faint background light within the cluster, they've essentially identified a population of what we call intra-cluster stars, that probably been spat out of the individual galaxies by their velocity, and excuse me. And so this represents a remarkably large population of stars, but because it's just this sort of thin layer of stars that are there in the cluster, because they're just individual stars rather than galaxies themselves, which are much brighter. And of course, concentrations of hundreds of billions of stars. So you've got this very faint background glow. It's probably impossible to detect it from the ground because, as you know, we've talked about this before. The night sky itself has its own natural brightness. Yeah, and that brightness comes from principally the atoms in the upper atmosphere, sort of relaxing after a hard day in the sun. They emit this glow, which we call the sky glow. And these, these new detections of this faint background of stars from the JWST, the Webb, the brightness of that is less than 1% of the brightness of the natural sky background here on Earth. So that would make it a very difficult task to measure from the ground. But put a telescope in space and you get rid of all that natural sky glow, and lo and behold, this population of stars has been revealed. And it's telling these researchers about the way probably galaxy mergers have taken place within the cluster. You know, if you imagine galaxies colliding together, as ours will do with the Andromeda galaxy in a few billion years, imagine that process. Then you're going to get stars spilling out into the background sky, and that's apparently what we're seeing.
Yeah, that's quite extraordinary. And I suppose the sensitivity of James Webb and being off-planet gives it so many advantages that, as you said, you can't detect from Earth-based observations because of the brightness of the sky. I suppose that equates, like if this only makes up 1% of the brightness of the sky, it equates to the sensitivity of the cluster in Western Australia picking up a mobile phone on Mars.
Yeah, it's
a similar thing, isn't it?
It is. That's exactly right. It's the same thing. Square Kilometre Array sees a phone on Mars. The James Webb Telescope sees this 1%, brightness of or it would be 1% if you were observing it from the ground.
That's quite amazing. Yeah.
And good work from the IAC, the Institute in the Canary Islands. They do great stuff there.
Yeah. You've got to wonder where it'll end. I mean, this thing's only been going for a few months, and so many things have been discovered. And
I did a talk last night here in Adelaide about the James Webb Telescope, and that was one of the questions. When's it going to end? How long will it last?
It just started.
Yeah, it's only just started, but it's a great question. And in fact, the lifetime of the Webb is dictated by the fuel it has left for it to do the station keeping, to keep it at the in its orbit around the L2, the second Lagrange point. And my recollection from when the telescope was basically installed in its service position is that whilst they expected it to have a lifetime of about 10 years, they'd saved so much fuel on the journey out there that they now pushed that up to 20 years. So,
oh, wow.
I think we've got a long time ahead to look at what's coming from the Webb. I think some of the discoveries that we might get from it will be just mind-bending.
Oh, I'm sure. Yeah, we've only just sort of scratched the surface to this point in time, and already it's just thrown up so many amazing discoveries. What will happen when it runs out of juice? Will it just float off into the Never Never?
It will probably wind up in some sort of stable orbit around that Lagrange point, and it will join other defunct spacecraft there because Gaia, which is a European astrometry satellite, that too is around the L2 point, and eventually that will run out of juice too. It's doing a great job at the moment, but so there'll be this sort of orbiting cluster of very expensive hardware, 1.5 million kilometers from Earth, and they'll probably just stay there because I don't think there's when you look at the cost effectiveness of going out and trying to tank them up with fuel a bit, it doesn't really work. It's better just to build a new one, put it into another orbit.
Yeah, well, it's probably cheaper. And by then, the technology will have advanced, so it's probably better building a new one than it is trying to gas up an old one.
Yeah, and there still remains the possibility that there might be damage to the James Webb Telescope because of micrometeoroid impacts. There's already that ding in the mirror that you and I talked about some months ago, which doesn't affect the performance. But I did notice recently that the prediction was that there will be about 2 micrometeoroid impacts per month in that location, and that's about what they're seeing.
Yeah, all right. Well, after 20 years, that adds up to a lot of hits.
It does, that's right.
All right. If you do want to follow up on that story, the paper has been published in the Astrophysical Journal Letters. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, let's head to Mars because this is probably a huge story in the scheme of things because we've always thought of Mars as a dead, cold world. But there's been indications in recent times that something's going on. They're finding evidence that there may be activity beneath the surface, although it was thought for a while that might just be remnants from its pre-existing life. But now it does look like there is some geology happening beneath the surface of Mars, and this could explain some of the mysteries that have been discussed in recent times.
Yeah, that's right. And it is a really great story, this. So you and I have spoken many times about the InSight lander, the little lander that's in Mars's equatorial region that had its own seismometer to measure volcanic activity, to measure earthquake activity, as well as the ill-fated thermometer that was supposed to be dug into the ground but never quite made it.
Yeah, that's right.
And it turns out that InSight is in a place where there has been recent geological activity. And a lot of the evidence from this, well, first of all, it comes from InSight itself. By measuring the seismographic record, you can tell where stuff is happening beneath the surface.
Sure.
And it turns out that a lot of that stuff is happening quite locally. It's not sort of global in its activity. But you can also tie in with this research from the several orbiting spacecraft, like Mars Express, the European one, Mars Reconnaissance Orbiter, and NASA spacecraft, because these have all got basically ground. Not some of them have got ground penetrating radar, but they've got a radar equipment that lets you map the height of features on the Martian surface.
Yeah,
and it turns out that the area where InSight landed, it's a region called Elysium Planitia. It's a big plain, hence the name Planitia. It turns out that is roughly a mile higher, 1.6 kilometers, than its surrounding terrain. So it's been bulged upwards.
Yeah.
And that's also supported by evidence of these, remarkable long cracks that there are in the surface, features that just look like the surface having split. And add to that some evidence of volcanic activity. There are sort of volcanic ash fields in this same area in Elysium Planitia that suggest that there was a volcanic explosion as recently as 53,000 years ago.
That's not very long in the scheme of things.
That's exactly right. One of the scientists who's done this research, which is actually at the Lunar and Planetary Laboratory at the University of Arizona, said that is, in geological time, that's essentially yesterday, 253,000 years ago, which is about right. But that's, really interesting. And I should mention, Andrew, that we're talking here about the lowland area of Mars. This is the whole northern hemisphere is lower in elevation than the southern hemisphere, where we've got all these mountains and craters and things of that sort. So the Elysium Planitia is a bulge in this lowland region. And the way this is being interpreted now, and the other thing that's folded into this, again, from orbiting spacecraft, you can actually measure the gravity field. And there are apparently details in that gravity field that suggest, along with all these other pieces of evidence, that yes, there is a magma plume, basically a mantle plume, very like the one that gave rise to the Hawaiian Islands here on Earth, a mantle plume where you've got hot stuff in the Earth's mantle, which is the bit between the core and the crust. And that poked through in Hawaii to make the Hawaiian Islands. And of course, because of plate tectonics, you get a chain of islands rather than just one big volcano.
Yeah.
Mars doesn't have plate tectonics, and we know that giant mantle plumes have existed before because the biggest volcanoes in the solar system are on Mars. And that's because they never moved. They just stayed put for probably hundreds of millions of years while the mantle plume spewed stuff out onto them, making these gigantic volcanoes. And it looks as though that process is still going on. That all the evidence points to a mantle plume, possibly something like 4,000 kilometers wide. This is not a small plume underneath the crust of Mars that's produced all this, the volcanic activity, the recent volcanic activity, the cracks in the surface, the elevation a mile higher than the rest of the landscape. So really quite remarkable, and telling us exactly, as you've said in the intro, that Mars is still active. And it's actually, in many ways, it's an encouragement for the possibility of finding living organisms on Mars, because a mantle plume like that is actually hot enough beneath the surface to drive fairly widespread melting of the ice that we know exists under the surface of Mars. And if you've got periods where there is effectively liquid water maybe embedded in the surface of Mars because of the mantle plume, just maybe there might be microbes in there that we might find one day.
Wouldn't that be exciting? And there's an image on the story I'm looking at from the European Space Agency's Mars Express that shows one of those splits you were talking about.
Yes,
and that's what it looks like. It just looks like you've torn apart a piece of cake. It's just, or a brownie, a rusty brownie.
You might have to explain that, because I think brownies are peculiarly Australian.
No, I thought they were fairly American, but
okay, yes.
Yeah, so if you've got a piece of cake and you just bend it like that and splits through the top, that's more or less what it looks like.
Yeah. It just reminded me, though, of one of the other pieces of evidence here that this volcanic activity, or this activity, is recent. And that is that when you look at, remember I said that it's bulged up by something like a mile. When you look at craters sort of towards the edge of that, they're actually tilted, which tells you that the craters are more ancient than this bulging. The bulging is a more recent phenomenon. That's
a key piece of evidence, isn't it?
It is, yeah.
Yeah. I'm very excited by this because, there's been all these, they've detected, methane pockets on Mars at certain times, is it? And,
that's right.
And they couldn't explain them. They've detected Mars quakes, and some of them couldn't be explained as being impacts by meteors or anything like that. But now it looks like they have found, well, we call it a smoking gun. We could call it that, couldn't we?
Maybe once in a while, maybe at some point we might see an eruption on Mars, which would be an astonishing thing.
Wouldn't it be amazing?
Yeah, it would be.
And of course, we're getting our own fair share of eruptions on Earth at the moment. The biggest volcano on the planet is currently erupting on the big island of Hawaii near the town of Hilo.
Yeah,
and I see today that they've called out the National Guard, so it's getting serious. Yeah. And my track record continues, Fred. I don't know if I've told you this before, but every time Judy and I have visited a volcano, The darn things erupted within a few months of us being there. Happened at Kilauea. We went to Kilauea, and 3 months later it blew its top.
Yeah.
We went to Mount Yasa in Vanuatu, and 3 months later it blew its top. We sailed past Mount Stromboli the other day. It went off last week.
Yeah. So it's all your fault, Andrew.
It is, yes. Yeah. We're the harbingers of death.
Charming. Well, yes. Certainly adds a new dimension to Space Nuts.
It does. I just think it's one of those weird coincidences. And, of course, we went up onto Mount Etna, so don't go there for a few months, would be my advice.
Yeah,
we were there.
Right.
It could be, although it erupted 2 months before we went on it.
So a bit ahead of time there.
I might reverse the trend, but we went past Mount Stromboli twice. It's an island, but it's technically a submarine volcano, like White Island and a few others. Yeah. But it actually caused I think part of the mountain slid into the Mediterranean and caused a 1.5 meter tsunami.
Yeah,
quite amazing and spectacular pictures I've seen of it, which is extraordinary, but not as spectacular as what's happening on Mars, I might say. I think that's a story that I'm very thrilled to hear because, the evidence was starting to stack up that it was not a dead world, and now it appears not to be. So that's pretty exciting stuff. Now, Fred, very quickly, let's talk about the latest with Artemis I. It's, I believe, on its way back home.
It is.
Will be soon.
Yeah, it's now left the gravitational field of the moon and is dominated by Earth's gravity. I can't remember the expected splashdown date, but I think it was
December 11th.
Yeah,
December 11th.
That's what I thought.
And it'll come down in the Pacific, I think.
That's right. It's not very far away. So zooming home as we speak, as it seems that everything has gone absolutely swimmingly. We've had lovely images, as you mentioned earlier on, extraordinary images of both the moon and the Earth, with the moon looking bigger than the Earth naturally. Because
that's a bizarre picture. I mean, you do not see that very often, but they've got a beautiful shot from one of the onboard cameras of the Orion capsule pointed back to Earth and the moon to the right, and the moon is bigger, which you don't see very often. That's that's on the cosmosmagazine.com website if you want to look at it. It's really good picture.
And that's because the spacecraft went a long way beyond the moon, in fact, in its mission. So yes, really quite amazing stuff.
I think I know why it's been such a perfect mission and nothing's gone wrong.
Go on then.
No people on board.
Well,
no one there to stuff it up. No, that's so disrespectful. It's nothing to do with it, but it does show that they really got it all perfectly worked out. The human factor's all on the ground, and it's been a magnificent mission. Just got to get it back down to Earth now, and then collect all that data they've been absorbing. But and it does pave the way for future Artemis missions and putting people and the first woman and the first Native American woman on the moon and establishing a base. It's really starting to get super exciting in terms of what comes next. So, we're all pretty thrilled, I think, indeed. But, so just a few days from now before she splashes down. This is Space Nuts, talking astronomy and space science.
You're listening to Space Nuts, the podcast about astronomy and space science with Andrew Dunkley and Professor Fred Watson.
Pretty sure that was your niece, Fred.
Maybe it was.
No, could have been. Now it's time to answer some questions. Now we got a question from our live audience via YouTube from Ben. Is that trophy cabinet getting bigger, Andrew? I don't know. Is it? Let me have a look. No, unfortunately not. We just finished the championships at the local club, and I think I finished fourth in one of my grades. So not overly I mean, fourth's okay, but I'd rather, fourth, last. You still lose. But that's golf. You lose 99% of the time. But, I've got a couple of extra pieces of volcano over there. So, I suppose it is getting bigger with non-sporting trophies. Let's call it that. Thanks for the question, Ben.
Actually, while you're talking about that, could I just, it's not a trophy, but I must show you something.
Okay.
For people on YouTube. Hang on a sec.
Oh, all right. Exciting. It's just like live radio with pictures.
Yeah. I'm sorry for people who are listening, but I was I gave a talk at the Astronomical Society of South Australia yesterday.
Oh, yeah.
And they presented me with this, and I don't know whether you can read it, but it is a picture, a photograph of asteroid, whatever its number is, I can never remember, 5691 Fred Watson. And it's captioned Asteroid at Large, which I like very much. So that's going to go on my...
Oh, that's a good one. Yeah. Those things are so special, aren't they? When people go the extra mile to... Yeah.
Extremely honoured.
I'm sure you were. I would have been tickled too. Yeah. Except they would have called me Fred and I would have thought that was weird. Anyway, now... Let us sort out some questions. And firstly, we have these are both sort of what-if questions, which I love. And this one, firstly, comes from Steve.
Hello, Space Nuts. This is Steve from Alaska. My question has to do with the sun and the end of its life. DART has me thinking about the future. If we felt like doing so, maybe it's possible in some untold number of years to fling celestial objects into the sun. What are the dynamics of extending the sun's lifespan by doing so? If we were to fling Saturn into the sun, would the sun live for an additional 10,000 years, 100,000 years? What kind of time are we talking about? What about asteroids or Neptune? And what about Pluto? I mean, no one will miss Pluto, right? Thanks, and I enjoy listening to the show.
Thank you, Steve. Oh, I think you've hit a nerve there. Oh, dear. Now, that's an interesting question. I mean, if we had the technology to drag Pluto out of orbit and chuck it at the sun, it'd probably mess other stuff up, but would it extend the life of the sun?
It's a great question. There's a bit of science involved in it as well. Well, I think the answer is probably not, because what the sun needs to extend its life is more hydrogen, just raw hydrogen.
Yeah.
And whilst the gas giants certainly have a proportion of hydrogen in their atmospheres, we've got a lot of other stuff as well. And so it's unlikely that throwing Jupiter in would actually extend the life of the sun. In fact, it would probably have exactly the opposite effect. It would be, a case of solar indigestion, I think, and you might get all kinds of spectacular solar.
We could call it gas giant gastric.
Yes, that's right. There's a pun there somewhere, isn't there? Gastric giant. That's probably what it would be. Yeah, or gastro giant. There you are. But the science in this is interesting because there's certainly been measurements made of the chemical components of stars, which provide evidence that they've gobbled up their planets. I'm trying to remember the exact circumstances in which that happens, but certainly, and you and I may have even talked about it on Space Nuts, that some stars where there is a suggestion that these are old stars with particular characteristics, but those characteristics are modified because there's the evidence that they've gobbled up perhaps silica and things of that sort, which make up rocky planets, for example. So there's a real a real scientific story here to the idea of suns and planets not being always entirely separated. So, well done, Steve. It's a great question.
Yeah, I'm interested in your take on chucking Pluto into the sun. I mean,
the sun would barely notice, unfortunately.
I'm sure you're right. Yes, we've got plenty of time to figure out how to keep it alive, because it's going to be another billion years before it's going to change the Earth.
Yeah, I think a more profitable line of approach might be, how do we get away from it? Because keeping it alive is really not on the cards at the moment.
They figured out how to do it in the movie Sunlight.
Oh, did they? Okay.
Yeah.
Oh, well, that must be possible then.
I think they filled a spaceship with nuclear weapons and just flew it into the centre.
Yeah.
Don't think that'll work.
No.
But it's science fiction, so everything works in science fiction.
So the sun uses up, just to put it in context, I think this is the right number. The sun uses up 6 million tons of hydrogen every second.
Yeah.
So, think about it.
Indeed, yeah. I even though it's so close to us and the light takes, 8.5 minutes to get to us, and we just accept it as the norm, it is rather an extraordinary piece of space.
Yeah.
And that's why we study it, because it represents examples of other stars that are so far away. We can learn what's perhaps happening there by studying this particular star, and we've got close-up opportunities to learn. I read the other day that they actually discovered a planet that was in the Goldilocks zone of its parent star, and it was the same. It was 1.2 times the size of Earth, which is an exciting discovery. Only one downer. It's a red giant.
Yeah, so there's probably lots of solar flares coming from it, or stellar flares coming from it. Yeah.
So not quite what we were looking for.
Near enough, though. I mean, it is extraordinary that we're discovering these things now about the size of Earth, which is the challenging part. So,
and I'm sure there are squillions of them out there. It's just finding them and keep analysing, keep finding, keep cataloguing, and then trying to learn a bit. The search continues for Earth 2.0. This one looked promising. I think it was in the Kepler system.
Okay.
But yes. Anyway, Steve, thank you so much. Yes, it doesn't look like even Pluto could save the sun. But then again, when you look at the mythology behind Pluto, why would it want to?
Yes.
Thank you, Steve. Now let's move on to a question from our favourite terraforming expert, Martin.
Hello, Space Nuts. Martin Berman Gorvine here from Potomac, Maryland, USA. Writer extraordinaire in many genres, with yet another madcap terraforming scheme.
At least he's honest.
Could you take an ice moon, such as Europa, and if the ocean beneath it is lifeless, electrolyze the water and use the oxygen to make breathable air, with the ice over it holding it in, perhaps with some additional support for that icy roof? Failing that, could the ice at least serve as a radiation shield for colonies established under plastic bubbles at the bottom of the ocean? Love you guys. Can't wait for the answer. Berman Gorvine, over and out.
All right. Thank you, Martin. By the way, I've nearly finished your book, which you sent me, and I'm that far through it. I'm really enjoying it. The Double Life, it's called. And I've even got an old-fashioned bookmark, which they made me in Italy. So I'm up to chapter 20 of Martin's book, The Double Life. So I'm really, really enjoying it. I'm busting to know what's going to happen, because it's all getting very interesting. So thank you for that. I've enjoyed it thoroughly. Now, what about the idea of an ice moon and doing all that stuff that Martin suggested?
Yeah, I love it.
But where's the but?
I don't know. So you've got to.
It'd be cold though, wouldn't it? Be too cold.
Yeah. It would be cold. I mean, you'd need. If you were going to, I hate to use the word, but colonize one of the moons of Jupiter, you would need to do extraordinary things to allow humans to live. And maybe plastic bubbles on the rocky surface underneath the ocean would be one way of doing it. But my only concern is, why would you do that? Martin points out quite correctly that you would get some radiation shielding from the ice crust above you, which you would certainly need, because the environment of Jupiter is very, very high in radiation with subatomic particles, not just from the sun, like we've got here in the Earth's vicinity, but also they come from Io. The volcanism on Io kind of releases subatomic particles into Jupiter's vicinity, and actually causes, I think it causes a radiation footprint on the planet itself because the radiation is so intense. So it's not a good place really for humans to be to start with. And I think, once again, I'm always thrown back onto this idea that if you're going to do mega engineering of such a large scale, the place to do it is on a spacecraft in space. You build your own. And yes, all right, you've got the liquid water on Europa, for example, and you can electrolyze that into oxygen and hydrogen. But there would be other ways of providing a reservoir of sustainability materials, if I can put it that way, with, for example, a halo world, one of these gigantic rotating wheels which provide gravity through rotation and let you almost build an environment similar to planet Earth. Not only that, you can then take it wherever you want to. You can journey through interstellar space for 10,000 years and turn up at another star system.
Yeah. That might be the way it'll happen in the long term, I imagine.
I think so too.
I mean, they made that video game called Halo, which has been turned into a TV series, and that's exactly what they had, these Halo rings that were all, self-contained environments, basically. I mean, they turned out to be weapons to destroy human beings, but it doesn't matter.
Okay. Yes, that's the downside, of course.
Yeah, well, it was in that story. But, the Master Chief saved the day. But, I'm starting to sound very geekish. But, I think that might ultimately be, when it comes to humans migrating to other stars and other planets, other worlds or whatever, that probably would be the way to do it, because we're probably going to be capable of creating an environmental type spaceship that can sustain generations of life.
Yes, that's right.
Faster than we can come up with a way of traveling fast enough not to have to do that. Does that make sense?
Quite.
Oh, good, because I forgot what I was talking about.
Yeah.
So what was the answer to Martin? Could work, but probably not worth it.
I like it. No, I bet it turns up in one of his books, though.
Oh, for sure. It's not in this one.
No,
this one's a bit more down to earth than that. But I bet it will. I'm sure. All right. Thank you, Martin. Lovely to hear from you again. And thanks to your book. I'll do a review when I've completely finished it, which will be in 6 months or so. No, I will.
Very slow reader.
I'm a very slow reader. I've got 3 going at the moment.
Yeah.
There's another book by a young bloke who listens to us, Obi. Hi, Obi. I've friended him on Facebook and I've bought his book. He's written a book about where we're headed in terms of the space travel and some of the things that we might achieve in the not too distant future over the next 20 years in terms of moving, putting people on Mars, etc. It's really good. And, 13 years old, and he's written a book and published it on Amazon. I think that's extraordinary. Well done, Obi. So very good. I'm reading that at the moment, which is on my iPad, so I can't grab it and tell you the exact title, which has escaped me for the moment, but I will next week. So thanks to everyone who contributed. Don't forget to visit us on the Space Nuts website, spacenutspodcast.com or spacenuts.io. And while you're there, you can catch up on episodes of Space Nuts and Astronomy Daily. Fred makes the occasional appearance on Astronomy Daily, and he doesn't even know it. But, every time something new pops up, we put some grabs of Fred into the mix. So listen out for that. Don't forget to visit the Space Nuts shop, and don't forget social media. We're all over that. We're on Twitter. We're on Instagram. We're on Facebook, a couple of different ways. The Space Nuts podcast group on Facebook is always good to to get involved in, because it's just a user-generated account that gives people a chance to talk about whatever they want to talk about, publish their astronomical photos, ask questions. It's fabulous.
Andrew,
Fred,
before we wrap up,
yep.
I want to give a shout out to two lovely people I met last week.
Yes, indeed.
In Fremantle, which is a seaside town near Perth, completely by chance, my colleague and I went to a restaurant called the Bib and Tucker in Fremantle, a very nice restaurant, and found two Space Nuts fans.
Wow.
Suna and Anthony.
So you did find both of them?
Yep. We're at the restaurant. Two fans, that's right.
Our only two fans.
Stumble across. And what I especially loved was when I had my cup of coffee at the end, they put SN into the foam at the top of it to signify Space Nuts. So
isn't that great?
Well done, Suna and Anthony. Thank you very much for the delightful meal that we had while we were there, and hope to run into you again sometime. Fremantle's a lovely spot.
It is a beautiful place. Yeah. All right. Oh, that's so nice. All right, Fred, we've got to go. Thanks so much.
Talk to you again soon.
All right. Catch you next time. Fred Watson, astronomer at large. Thanks to Hugh in the studio for pushing all the buttons and keeping the coffee hot, or whatever it is he does. And from me, Andrew Dunkley, thanks for listening. We'll catch you on the very next edition of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.